today I have something new for you, a lesson or a way to draw alcohols. So I have a few steps outlined for drawing the alcohol, and then I'm going to be going through an example of 3-butene 1,2-diol. So let's go through the steps first, and then we will try to draw the diagram. So when we are trying to draw alcohols, our first step is to identify the parent alkane in the molecule. Once we have identified the parent alkane, we need to draw the parent alkane first, which is the longest carbon chain that contains the alcohol group. Second step, we have to determine the location of the hydroxyl groups from the name. And then, once we have determined the locations of the hydroxyl groups, we need to add those hydroxyl group or groups into the diagram. Third step, if there are any other branches present, we need to add those to the diagram. And the final step is to fill the hydrogens so that all carbons have a total of 4 bonds each. So, since we have gone through the steps, let's try to draw 3-butene 1,2-diol. So, let's look at the name first and try to break down what this name tells us. We have but. We have the part but, which tells us that this is going to be a 4-carbon chain, so 4 C's. Then we have this interesting information. We have En. En represents an alkene. That means there is a double bond. Now, since the molecule has a double bond, we need to know where this double bond exists. And the location of this double bond is indicated by this number in the front. It's this double bond in this molecule is located at position 3. Okay, so that's what that 3 represents in the front. And at the last point in this name at the end, we have an ol. Ol represents it's an alcohol, representing that it has OH group. And then it says there's di. Di means there are 2 of them, so times 2. So in other words, we have 2 OH groups in this molecule. Once we know that we have 2 OH groups, we need to identify the locations of these hydroxyl groups. The locations are given before it, location 1 and location 2. So, since we have 2 alcohol groups, one of them is going to be located at position 1 and the second one is going to be located at position 2. Now, once we have looked at the name, now let's begin to try to draw this molecule. So, first step, the longest parent alkane, 4 carbons long. 1, 2, 3, 4. We have our 4 carbons, and initially we will have to draw it as an alkane, so all single bonds. Now, going back to the name, we have drawn the but part, which is 4 carbons. Then the new characteristics of this molecule, there is an En, which is a double bond at position 3. So we will, let's say we are starting to count this molecule from the left hand side. Let's number our carbons so that it's easier for us. This is carbon 1, 2, 3, 4. Now going back, okay, on the third carbon we have a double bond. So starting from the first carbon, 1, 2, 3. On the third carbon, that means between third and the fourth, we have a double bond. And so we have added a double bond on position 3. Now the molecules indicate that there is alcohol groups, which are OH groups, hydroxyl groups, in the molecule, position 1 and 2. So we will add the hydroxyl group O H, position 1, OH, position 2. It does not matter if you put it on top or the bottom. It is, since it's a single bond between carbon 1 and carbon 2, and carbon 2 and carbon 3, these hydroxyl groups are free to rotate. These carbon molecules or carbon atoms are free to rotate. And therefore, it is, you can place it on top or the bottom. Now, once we have that done, we have completed steps 1, 2, and 3. The last step is to fill hydrogens so that we can satisfy the bonding capacity of carbons, which is 4. So each carbon has to have 4 bonds. Looking at carbon 1 right now is bonding to 2 other atoms. It's using 2 of its 4 bonding capacity. So we have to add 2 more hydrogens to it. The second carbon has 3 bonds right now, needs 1 more to get to 4. Carbon 3 has 3 bonds. There's a double bond and a single bond. So we have already consumed 3 bonding capacity. We have 1 more left to go. You can place it on the top or you can place it at the bottom. And the last carbon has consumed 2 out of 4 bonding capacity. We need to add 2 more hydrogens. Now you can place it on the top and the bottom, or you can place it at a little bit of an angle. And the reason for that is the bonds would like to be as far away as possible from one another because of the repulsion between electrons. And that's why sometimes you will see them drawn on an angle away from that double bond between the carbon and the carbon. And that it would be the structural diagram for alcohol. If you would like, you can also draw it in the line structural diagram form, a little bit more condensed. So the steps would be exactly the same. We will draw a 4 carbon alkane first. 1, 2, 3, 4. I like to place a dot there indicating that this is the carbon. Alright, so we have the 4 carbon alkane drawn. Now we'll add the double bond or the alcohol groups. We can go either way. We can add the alcohol groups if you would like first. Alcohol groups would be on position 1 and 2. So I can place one on position 1 and position 2. That's my alcohol groups. Remember the dots representing the carbons. So 1 and 2, I have the alcohol groups. And the other characteristics in the molecule is on position 3, we have a double bond. So between 3 and 4, so 1, 2, 3, between 3 and 4, you will see there is a double bond. And that would be the line structural diagram for 3-butene 1,2-diol. I hope this helps in understanding how to draw alcohols, the complete structural diagram, as well as the line structural diagram. Have a great day.